Hi guys, it's Miss Cullen here, and I'm going to do a quick video on the CPCTC extra worksheet packet that I gave you. So if you're still struggling with this, the basics of this is always, the first thing you look at is your given information. Okay? You have to know sometimes some things to do with that given information. The main thing you're going to do first is label it. So it says C is the midpoint of AD, this line here. You have to know that midpoint divides a segment into two congruent parts. So you're going to label that on your picture. Okay? Down here you'll also see that I wrote that as my first statement, and my reason is that it's given to me. Okay? Now I'm going to go to my next given information here. They tell me that C is also the midpoint of EB. So I'm going to come over here and I'm going to make sure to label that EB. Okay, I'm going to give it double lines because if I give it single lines, then it will say it's congruent to AC and DC, and that's just not true. All right, so now I have two sides listed. And it's very important that you understand what your end goal is here. You have to understand that you're trying to show this triangle here, ABC, is congruent to this triangle here, ECD. Why? Because then we can say anything in the triangle is congruent to something else in the other triangle. That's what CPCTC is. Okay, so we're looking for one of our congruency shortcuts. These by now you also have to know. Okay, there's 5 of them that work. Side, 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 angle, side, or I already said ASA, and hypotenuse leg. Okay, the only time you're really going to use hypotenuse leg is when you have a right angle. Remember that the hypotenuse is across from the right angle, and a leg is just one of the other sides besides the hypotenuse. Okay, so here I don't have a right angle, so I know I'm going to use one of these for. I need either another side or another angle. Once again, Ms. Cullen has written down this on the board a million times. There's only 2 assumptions we can make. Okay, so by now you should know those. Our 2 assumptions are either 1, vertical angles, or 2, reflexive property. So reflexive property is a shared side in the triangle. The vertical angles are angles that are across from angles that share share a vertex, and they are not touching. So they're across from each other. Okay, so these are the only 2 assumptions we can make. These are the basic 2 things here that you need to know. So maybe you're going to write this on every sheet that you do until it really sticks with you. I need something else here. These are my 2 assumptions I can choose from. Do I have reflexive property? Do I have a shared side from this triangle to this triangle? No, they don't share a side. They're facing each other. Do I have vertical angles, 2 angles that share a vertex? Yeah, right here at C. Okay, a lot of the times if you have a midpoint with 2 triangles, you might have that. Okay, so I'm going to label my vertical angles. We label vertical angles, we label them with an arc. Okay, I think a lot of our struggles here is we don't know how to label our photos. You label segments. Segments are these with the lines across, with tick marks, and you label angles with arcs. Okay, so now I have my picture labeled. Once you have your picture labeled, it's pretty simple because you're literally taking your pen and you're saying this is called a what? A side. This is called a what? An angle. And this is called a what? A side. This is called a side. This is called an angle. And this is called a side. Bam, it's right there for you, right on your paper. SAS, SAS. These 2 triangles, ACB and DCE, are congruent by SAS, side angle side. So just for, time reasons, I already have it filled in for you here. Okay, C is the midpoint of EB. That's my other given. angle ACB and angle ECD are congruent, okay? Now, you'll notice I have to name the full angle. I can't just say angle C and angle C. No, this is not angle C, that's not angle C, okay? It's ACB and ECD, all right? So why vertical angles are congruent? Then I can say the full triangles are congruent because I have 3 pieces of information here. Once you have 3 pieces of information, you're pretty solid to show that your triangles are congruent. Lastly, what they want me to prove, though, is not just the triangles. They want me to prove the angles, A and angle D. Okay, so look over here. This is where the CPCTC thing comes in. A, I'm going to mark with 2, and D, I'm going to mark with 2. I can now say that these are congruent. Why? Since I showed a side across from it, boom, boom, boom. Remember I said the arrow thing? That has 2 tick marks congruent to another side over here. I know that the 2 angles that are across from these sides are going to be congruent. By CPCTC, corresponding parts of congruent triangles are congruent. Same thing here. Whatever angles across from the purple tick mark here, B, is going to be congruent to the angle across from the purple tick mark here, E. Okay? So that's what CPCTC says. You can start labeling everything. I can now say these are congruent. Okay? All my angles are congruent. All my sides are congruent, right? These are the shortcuts that help us see that. Okay. Here real quick. Same thing. My given information, NO, is congruent to PQ. Okay, don't get too excited. Make sure you're labeling your given information. Angle. This is where I think we're also getting a little confused. Angle ONQ. Take that pencil, people. Follow that. ONQ. It's being cut off by this line here. Okay? Angle PQ. We always mark the middle letter, the Q and N. Okay? QN is congruent to that. So now I have an angle and now I have side. I either need another side or another angle, right? If I need another angle, it needs either here or here, but I can't say that about either of them. We don't know that these are parallel, so we can't do alternate interior angles. Be careful. It doesn't tell us that it's parallel. So the only thing we can assume here without the given information is reflexive property of vertical angles. Reflexive property says that a triangle shares a side with another triangle, bam, right here. Okay? So NQ is congruent to NQ. Now I have side, angle, side, and I have over here side, angle, side. Okay? Now that I'm showing them congruent by SAS, I can get to the point where side NP across from my red angle is congruent to the side or in this triangle across from my red angle, OQ. Okay, I hope we're starting to see that and how that makes sense, that those are going to be congruent because their angles are congruent. Okay, just with the ang legs, think about the ang legs. When you made that angle, there was only one other third side you could have. So, bam, here's my given information. NO is congruent to PQ. Y given. Angle ONQ congruent to angle PQN. Y given. Okay, what happened here? Well, we said that NQ was congruent to NQ. Oh, sorry. Q congruent to NQ. Why? It is reflexive property. Okay, so reflexive property. Okay. And then the next statement here is that NQO is congruent to QNP, the triangles, right? We're saying these triangles are congruent by side, angle, side. Side, angle, side. Okay, lastly, these are congruent by CPCTC. Okay, that's what we're proving here. All right, one more real quick. Given your information, I'm just going to label this one with you guys real quick. I'm really hoping by now you're starting to see it. Given information, IJ is congruent to KL. Bam. IJ is congruent to, these are congruent to. Okay, that's what this says up here. Okay, it's the only given information for me. You should see it by now. Do I have vertical angles? No. So the only thing I can assume is, once again, they share this side, 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 side. These are congruent by side, 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 which means that the angles across from my pink lines are going to be congruent. And that's what I'm proving by CPCTC. So you should be able to fill that in. I hope this video helped. Have a nice day.